Question 5. A student adds large pieces of copper 2 carbonate to dilute hydrochloric acid. The copper 2 carbonate is in excess. Part A. Complete the equation by adding the state symbols for the products. So on the product side we have copper chloride. Copper chloride is soluble in water. So we will write aqueous because there is a solubility rule that all the chlorides are soluble in water except silver chloride and lead chloride. So that's why the copper chloride is in the aqueous state. Water is in the liquid state and the carbon dioxide is a gas, so we will write G here. Now part B. Figure 5.1 shows how the mass of the reaction mixture changes with time as the reaction proceeds. And part 1 is, in another experiment, powdered copper 2 carbonate is used instead of the large pieces of the copper 2 carbonate. All the other conditions in the mass of the copper 2 carbonate stay the same. Draw a line on the grid to show how the mass of the reaction mixture changes with time. So if we are using the powdered copper 2 carbonate, it means we are increasing the surface area. So the rate of the reaction increases. So it will start from this, but the graph will be a steeper curve. So it will look like this, but it should end on the same line because we are just increasing the surface area while the concentration and the other thing stays the same. Okay, now the next part 2. The initial experiment is repeated using a large pieces of the copper 2 carbonate and the hydrochloric acid of a higher concentration. All other conditions stays the same. Describe and explain the difference in the rate of reaction when the hydrochloric acid of a higher concentration is used. So whenever we increase the concentration, the rate of reaction increases. So we will start the statement by writing rate of reaction increases. And why the rate of reaction increases? Because higher concentration means more number of reacting particles per unit volume. So if you have more number of reacting particle, it means frequency of effective collision increases. Okay, so this is the complete answer. Okay, next part C is excess copper 2 carbonate is added to 22.0 cm cube of 0.500 mole per dm cube hydrochloric acid. So 22 cm cube is actually the volume because cm cube is the unit of the volume and mole per dm cube is indicating the concentration of hydrochloric acid. Now calculate the volume of carbon dioxide. So we have to calculate the volume of carbon dioxide released measured at room temperature and pressure and give your answer to two significant figure. So for such cases, always apply a 3-step method. So step number 1 is calculate the moles of the known substance. So the moles of hydrochloric acid and the values that are given, these are the volume and the concentration. So in relation with the moles, the formula is moles equals to concentration into volume. So the concentration is 0.500 into volume, which is 22.0. But the volume is given in cm cube, so we have to convert that into dm cube. So divided it by 1000. So if you do this calculation, 0.5 into 22 divided by 1000, we will get 0.011 mole. And this is a mole of hydrochloric acid. Step number 2 is apply the ratio, mole ratio. We apply the mole ratio to calculate the moles of the unknown substance. So the mole ratio is applied between hydrochloric acid and carbon dioxide. And how can we get the values of the hydrochloric acid and the carbon dioxide? We'll take the help of the chemical equation. So in the above chemical equation, the hydrochloric acid moles are 2 while carbon dioxide is 1. It means the ratio is 2:1. So 2 moles of hydrochloric acid produces 1 mole of carbon dioxide. So if we take 0.011 mole of hydrochloric acid in the lab, so how much carbon dioxide produce? X. Now simplify this, 0.011 divided by 2 into 1. So if we simplify this, we'll get 0.0055 mol of carbon dioxide. Now step number 3 is we have to calculate the volume of carbon dioxide, and the formula of volume in relation with the mole is volume equals to mole into 24 dm3. Mole is 0.0055 multiplied by 24. So the answer is 0.132 dm3. 24 is actually the dm3. Okay, so but examiner said that we need the answer in two significant figures, so the answer will be 0.13 dm3. The unit is already mentioned here. Okay, now the next is D part 1. Describe the observations made when a few drops of aqueous ammonia are added to an aqueous solution containing copper 2 ions. So this is actually the cation test. We have two chemicals that we use to identify the cations. One is sodium hydroxide and other is ammonia. Here examiner is asking about the aqueous ammonia. So whenever we added aqueous ammonia in copper 2 solutions, it gives light blue precipitate. Now the next part is excess aqueous ammonia is added to an aqueous solution containing copper 2 ions. It means when you are adding more ammonia into the same solution, the precipitate will dissolve and it forms a dark blue solution. So we can say dissolves to form dark blue solution. Okay, next part 2 is an ionic compound of copper has the formula Cu2O. Deduce the oxidation number of copper in Cu2O. So copper is a transition metal, so in that case we'll follow the crisscross method. So nothing is written with oxygen, so it means it is 1. So the oxidation number of copper is 1 and the charge is positive 1 because copper is a metal and metals are always positive. Okay, next is part E. Describe how to prepare crystals of ammonium chloride by reacting aqueous ammonia with dilute hydrochloric acid. So ammonium chloride is basically a soluble salt. So to prepare soluble salt we have two methods. The first method is if the starting material is insoluble, then we have to write the excess reagent method. But here examiner is using a word aqueous ammonia. It means the starting material is soluble in water, as the dilute hydrochloric acid is also soluble. So in such cases the technique that we follow is titration. But this is a 3 marker, so we are not going to write a detail about the titration. We will only give the like a basic hint to the in our answer script that titrate aqueous ammonia with hydrochloric acid. And then we don't need to mention the other details related to the hydrochloric acid or the ammonia, that we have to take it in the burette, one in the conical flask, add the indicator and the color change, stop the titration, note down the burette reading, because we have been given with such a very small space. So instead of that we will write a second step that repeat the titration without indicator. As we repeat the titration without the indicator, so we will get a pure solution in the form of filtrate. And then because we need a crystals, so we will heat the filtrate to crystallization point, or we can use the word saturation point. After heating, allow the solution to cool. So that crystallization can take place. And then we have to write filter and dry the crystals between filter papers.